Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience. And today I want to talk about what may seem like a pretty unlikely relationship between diet and disease. Specifically, I want to talk about some new evidence that there may be some interesting interaction between one of my favorite herbs on the planet and one of the most common brain-related diseases on the planet, Alzheimer's disease. And so, one of my favorite plants and flavors in the world is basil. You can see my basil right here. And so, it's easily one of the most recognizable flavors and herbs out there. I use it on pretty much everything. If I'm making a sandwich, toss some basil on there. If I'm, making a soup of pretty much any kind, cut up some basil and toss it in at the end. I try to always have some basil growing, even in my tiny little apartment with 0 yard space. It's one of those things that I think can make even a pretty bad meal taste better than bad. Hey, Scott, thanks for jumping in here, man. Oh, and thanks for the award. I appreciate it, dude. So it's also like an incredibly diverse group of herbs, right? I've seen estimates that there are anywhere between 50 to 150 varieties of basil. And so I had to abandon the Thai basil and the purple basil that I was growing when we moved from our last apartment to this one. But it's always been pretty amazing to me how much variety and flavor there is just within this one group of herbs. And so, most people have probably just eaten sweet basil or Genovese basil, which is, the sort of standard basil that you'll find in grocery stores in the United States. That's what this one is. And so, for me at least, it's sort of standard basil flavor, right? And it's reliably delicious and perfect. And, it's what I'm growing right now because, the grocery store actually didn't have anything other than these kind of basil plants with their roots, sitting in water, which is fine. And I got this one about 2 months ago, and it's been growing like a champion, and we've been munching on it ever since, right? But, if you ever had like pho, you've very likely had some Thai basil delivered along with it. And I love Thai basil, a little spicier, definitely has a little bit more of that anise, licorice-y kind of flavor than sweet basil. And then, there's so many others, right? The purple basil that I was growing for a while in my aero garden was absolutely delicious and very beautiful. And, even more anisey than Thai basil. And then there was lemon basil, which has like a legit citrusy smell and taste. So good. Anyway, so this one category of herbs produces an absolutely prodigious portfolio of flavors, right? And all of that variety in flavor corresponds to the presence of specific molecules. And the ratios of which molecules are present will determine the flavors of the given basil. Estragol, limonene, eugenol, linalool, eucalyptol, right? There's just a whole ton of aromatic compounds that tickle specific constellations of receptors in our olfactory system. And depending upon which specific combination of receptors are tickled by those molecules, we perceive the different flavors present in different types of basil. Okay, so, I don't have a PhD in, culinary arts or horticulture, so why am I going on and on waxing poetic about how wonderful basil is? Well, a study was published in Frontiers in Aging Neuroscience a few days ago, right here. We can get rid of that. Maybe we'll do that. Okay. And so this is a group of scientists from all over the place, right? Wake Forest in North Carolina, PES University in Bangalore, India, the University of South Florida, and then the National Institute of Animal Biotechnology in Hyderabad, India. Pretty cool. And so, this article title is probably at least a little bit kind of inscrutable to people who aren't like neuroscience nerds. We have microbiota, free fatty acid receptor, amyloid beta, neurotoxicity, proteolysis, senescence, all in the same title, right? Quite a mouthful of buzzwords. And so let's just translate at least a little bit of this jargon here. So what this title is saying is that the activation of this particular type of receptor reduces the negative effects of one of the things that we know is at least associated with a certain disease, right? One of the most common diseases in the world, Alzheimer's disease. And so Scott says, the place by me that specializes in Belgian beers and artisanal pizzas makes a margarita pizza that comes with a little heap of basil in the center. Yeah, I love that. We have a place that does that too. Yeah, I love it. There's never too much. And so, all right, so I chatted about Alzheimer's and dementia almost exactly a month ago at this point, discussing the progress that's been made in using artificial intelligence and machine learning to recognize when someone is developing Alzheimer's disease far earlier than we currently can by deploying this artificial intelligence to assess brain scans, enabling us to pick up on the super subtle signs that someone might be starting to develop the condition. And so, I'm happy to provide a link to that discussion if anybody's interested. It is a pretty cool story, but to briefly recognize how gigantic of a concern this is, Alzheimer's disease is the most common cause of dementia. And dementia is just an umbrella term that's like a category that incorporates the progressive loss of a whole variety of brain-related capabilities, right? Memory, of course, is the classic component of our consciousness that deteriorates with dementia, but everything from mood to social interaction to personality, they all begin to radically change and deteriorate as the brain, suffers the consequences of the progression of these diseases. And so there's a bunch of different types of dementia, right? It's not just Alzheimer's. Frontotemporal dementia, Lewy body dementia, which is the one that Robin Williams was confronting, vascular dementia. There's a whole ton, right? And by the way, it is quite common for people to suffer from multiple types of dementia simultaneously, right? It's not like you must either have Alzheimer's disease or vascular dementia. People often have, signs of more than one cause of dementia. And so there are estimates that someone in the world develops dementia every 3 seconds. And so, as you can see here, the rates at which dementia is being diagnosed is predicted by most people to escalate worldwide moving forward. And so this is particularly going to be the case in lower and middle income countries, though rates are expected by most people to gradually rise in higher income countries as well. The story's a little bit more complicated than that. We'll touch on that at the end. So in the United States, here we go. In the United States, right, Alzheimer's disease is already one of the leading causes of fatalities. It's just under strokes and just above diabetes. And by the way, the relative cause of fatalities caused by Alzheimer's disease and dementia look pretty similar worldwide. And so, I'm sure basically exactly 0 people need to be convinced that Alzheimer's and dementia are some of the top causes of human suffering worldwide. While there's been quite a bit of progress in understanding the kind of basic biology of Alzheimer's disease, there really hasn't been any particularly compelling progress in developing new treatments for the condition. And so, there has been some recent controversy regarding a new drug that was just FDA approved called aducanumab, or Aduhelm, which is, there's a whole story that maybe I'll talk about in the near future. But the short story is that there's this drug that was approved by the FDA for the treatment of Alzheimer's disease, despite the protestations of subject matter experts, right, like scientists and physicians, and some of the largest biomedical or specifically medical institutions in the country and in the world, including Massachusetts General Hospital, which is one of the top biomedical institutions in the world. They've announced that they will not be using this medication due to the dearth of evidence supporting its efficacy. It's kind of controversial, but yeah. So aducanumab and Aduhelm is the most recent innovation in the world for the treatment of Alzheimer's disease, and tons of scientists and physicians have publicly announced that they, not only wouldn't endorse its use as a treatment for the disease, but that they don't think it should have been approved to begin with. And so. Adicab, I love the Genesis song. Yeah, aducanumab. But yeah, Aduhelm is like the brand name, right? It's like Kleenex versus facial tissue, But anyway, so that's basically the state of affairs when it comes to treatments for Alzheimer's disease and dementia. Despite the massive progress that's been made in understanding the basic neurobiology underlying the condition, there just aren't all that many new treatments, and certainly nothing approximating a cure, right? Okay, so we've now explored 2 topics that are intuitively pretty unrelated: Basil and Alzheimer's disease. Both are interesting in their own rights, of course, but this paper connects some of these otherwise unconnected dots. Okay, so let's begin at the start. All of us, every one of us, is a coral reef. Okay, obviously we're not coral reefs, right? We're not literally coral reefs, but just like this coral reef, we are the host of a huge repertoire of living microbes, or at least microbes, depending on whether or not you consider viruses to be living. But, we host all of these organisms, these teeny tiny little organisms like bacteria and fungi that inhabit, various parts of our bodies, everything from our mouths to our eyes, our armpits, and most relevantly, our gut. And all of us have slightly different connections, between relationships between the microbes that inhabit our gut, but then also different collections of these microbes. So we as Homo sapiens, we literally evolved alongside these microbial species. They depend on us, and we depend on some of them. But when we look at which specific microbes inhabit all of us, there's quite a bit of variability, right? We don't all have the same microbes that inhabit our bodies. And so depending on where you live, who your parents are, particularly your mother, what you eat, the way you were born, what kinds of sex-related hormones are swimming through your blood, what kinds of infections you've had and what kinds of medications you've had to take as a result, and what you do day to day, right? Your lifestyle. You'll have a unique distribution of these microbes. And so, even more importantly, some of those microbes are capable of influencing our biologies in various ways. And so I can link, I'm happy to provide a link to the article in the conversation from which this paper is sourced. In case anyone's interested in checking out, it's about the microbiome more broadly, clearly. And this is focusing specifically on some of the favorable interactions that, of these microbes, right, with various parts of our bodies. And so I can also, there's also a more sort of scientific article that gets into the more granular detail of these relationships, and I'm happy to link if anybody is interested. Scott wants it. All right, let's get it. Here we go. Let's see. Nope, that's that one. That's that one. Yeah, here we go. I've got to do this. Sorry. All right, here we go. Boop, boop, boop. Basil, Frank says, basil just intuitively seems to smell, taste good for you. Yeah, almost medicinal, right? Although, I mean, there are some pretty big differences in the way that some of them smell. But yeah, I totally agree. It's just like, it feels good just to smell. But and then, there's also a more sort of scientific, this is the first one that I mentioned in the conversation, Scott. And then there is a more sort of scientific article. Both of them are free. They're not behind paywall. The other more scientific one is very extensive, much more than this, but, or I can't copy in the app. Oh, really? Is that right? That's frustrating. But anyways, yeah, so when it comes to the gut, which is, by the way, the largest reservoir of these microbes that inhabit our bodies, when it comes to the gut, these microbes can take, some of the molecules that we eat, convert those molecules into new molecules, and those new molecules can interact with our bodies in unique ways. And so in some cases, the presence of certain microbes can result in a predisposition to various diseases and disorders. Everything from obesity, psoriasis, irritable bowel disease, or irritable bowel syndrome, but then also like cardiovascular disease and colon cancer. All of these have been associated with high levels of specific microbes. And there's even evidence that the presence of certain microbes is associated with, various psychiatric conditions, termed the psychobiome. And so, that's kind of a fun. I've talked about that in the past if you want to check it out. But anyways, while a lot of the discussion associated with the microbiome tends to focus on the negative effects of certain microbes, there are also beneficial relationships that we can have with certain microbes. And today's paper focuses on that kind of a relationship. So specifically, certain microbes generate what are called short-chain fatty acids, which have been associated with reductions in Alzheimer's associated signs, right, within the brain. So short-chain fatty acids are exactly what they sound like. Here we go. They're just fats, right? Fatty acids, fats that happen to have short chains, right? And that may seem sort of unintelligible, but so when I say chain, what I mean is the sort of squiggly connection of carbon atoms that are connected in a series that dangle off of a part of a molecule that makes it also an acid, right? So fatty acid, the fat part is the squiggly line, the acid part is the more complicated stuff on the side of the molecule. And so, when you see those zigzags sticking off the sides of each of those molecules, those are the chains, right? And each corner, each little apex along those zigzags is a carbon atom. And so when it comes to a short chain fatty acid, those zigzags are particularly short, right? Like shorter than the ones that you're seeing here in this list. And so there's this little receptor in our bodies, a receptor that works in a way that's sort of similar to like a dopamine receptor or a serotonin receptor, right? But it's in a variety of different parts of the body. And importantly, this group found that neurons also produce this receptor. And so, in other words, the brain might also be sensitive to the effects of these little fatty acids. Okay, so what is this receptor? This is the free fatty acid receptor 2, or FFAR2. And so it's basically a sensor, right, for specific types of molecules that are often produced by those little microbes that inhabit our gut, right? And it turns out that those short-chain fatty acids, which, once again, are produced by some of those beneficial microbes that can inhabit our gut, those short-chain fatty acids bind that receptor, FFAR2. And so it also turns out that when it comes to the microbiome and gut of someone who has Alzheimer's disease, they tend to have rather low levels of those short-chain fatty acids. So that's sort of where this group started. That was the sort of starting point for them. They started out by finding that if they inhibit that receptor, that FFAR2 receptor, the receptor that those beneficial short-chain fatty acids bind, if they inhibit that receptor, some of the molecular signatures of Alzheimer's disease tend to get worse, right? So for anybody who might already be familiar, levels of amyloid beta were higher when that receptor was inhibited in neurons. Free fatty acid, yeah. Hashtag free fatty acid. Let them go. So like any neuroscientist or pharmacologist would, right, given that relationship, that if they inhibit that receptor, amyloid beta levels increase, they imagine what would happen if they just stimulated that receptor directly, right, taking out that microbial middleman. And so they used a computational system, that what we call in silico screening, to get a sense of which molecule out of over 144,000 molecules, which one of group of them might interact with that receptor. And they landed on 15 molecules. So 15 out of 144,000 molecules. So, and then for whatever reason, it turned out that they ended up honing in on a particular molecule called fenchol. So here's fenchol. And there's zero reason for anyone to know what on earth fenchol is or means. And frankly, in my opinion, it's a kind of like an abusive sound, of a word to use for, as a name for what this molecule is. Fenchol is the molecule that gives basil its basily smell and taste. Evidently it's like the basil molecule. And so like without this molecule, we'd just be like munching on like weirdly bitter or anisey, licoricey, or citrusy leaves, right? It wouldn't have that lovely sort of classic basil flavor. And so it turns out that this molecule happens to bind that free fatty acid receptor. And so, that receptor that the beneficial short chain fatty acids that are typically produced by some of the beneficial microbes that inhabit our gut will tend to bind. And then when bound, right, when that receptor is bound, may tend to reduce the production of amyloid beta plaques. Pretty cool. So in other words, it seems to be the case that this molecule, fenchol, binds the same receptor that the products of those beneficial microbes bind, right? And when that receptor is bound, the stuff that we think is a part of the cause of Alzheimer's disease tends to be produced at lower levels, right? They have evidence to suggest that it seems to amplify, right, one of the systems in our cells that clears out problematic proteins and molecules via the lysosome. So in cells, there's like two main sort of like recycling facilities that get rid of, dangerous or misfolded, misproduced proteins and molecules. You have the lysosome, which is the one that they're honing in on, and then the proteasome. I almost focused my research on the proteasome, but they do very similar things. They just sort of break molecules down into simpler components to basically be recycled and used for other things or just excreted. So they're honing in on the lysosome. And so they do similar things, but they tend to focus, lysosome and proteasome tend to focus on different types of molecules. So they can do some of the same exact things, but and they're different parts of the cell, right? But basically that's what they are. They get rid of stuff. And so that's super fun, right? So eat more basil would be the takeaway, right? And, frankly, I eat basil whenever it's even like marginally reasonable, like even when it's not particularly reasonable. So like, my daughter didn't finish a bagel bite last night. You better believe that I warmed it back up and put a little soppressata salami on top and then a silly number of these, fresh basil leaves. I'm basically eating like an anti-Alzheimer's bagel, right? Not quite. I mean, I do that regularly, but these data are super preclinical, right? Super preliminary. And so the evidence is based in nematodes and in mice, C. elegans and mice. And, to be clear, like my research was at the same level. I worked with mice. So I'm, by no means am I denigrating the research, but I've just seen a whole bunch of headlines making the rounds that suggest that basil might prevent Alzheimer's disease. And that's absolutely not where we should go with these data. So Scott says fenchol sounds like either a fancy cheese. Yeah, I could go with you there. Or a pretentious font. Yeah. And then Scott says, thank you for saying hone instead of home, unlike most people who are, of course, wrong. And then I want to find craft basil beer. I don't think I've ever seen that. That's an interesting idea. I could imagine that working. I could imagine basil soda, like, that wasn't fermented or anything. I could imagine that being pretty good if it's like a little sweetened maybe. Citrus and basil. Well, I guess sort of like a mojito. Well, I guess mojitos use mint. What is it? Caipirinha? I think that uses basil. I don't know. Anyways, I agree. Delicious in beverages. Okay, so we've seen a bunch of these headlines that suggest like basil prevents Alzheimer's disease, and that's just not where we should go with these data. At least this research at this stage. And so firstly, I suspect that the amount of this molecule that would be necessary to achieve anything like what they're talking about would be like so massive that you'd have to eat a forest of basil to get enough of that molecule. And even then, I'm guessing that this molecule, like in particular fenchol, isn't likely the most effective strategy to target this receptor, FFAR2. So in other words, this study, what it's doing is it's putting a target on a particular receptor as a potential strategy to minimize the likelihood that something we think causes Alzheimer's disease, more on that in a little bit, something that we think causes Alzheimer's disease will tend to accumulate, right? Amyloid beta. Not that we should all just be gobbling up tons of this particular molecule or basil. But that said, I mean, this is not the first study to connect fenchol, right, that molecule that's present in basil, a lot. So basil isn't the only plant that produces fenchol, right? So a bunch of other plants produce it. So from aster flowers to cannabis produces fenchol. This isn't the first study to connect this molecule to Alzheimer's disease. And so there's a review that touches on one connection between fenchol and Alzheimer's disease, though it's through a different mechanism in this study, interestingly. But I'm happy to share a link to that review if anybody's interested. But so I also think it's worth at least acknowledging that there's kind of a growing suspicion among some neuroscientists that perhaps the whole framework of how we understand Alzheimer's disease has been at least somewhat misguided and maybe a little biased. And so there's an article in Stat News that gets into some of this sort of controversy and debate, but central to their point is two main things. So, first, we still don't have any effective drugs to treat Alzheimer's yet. Second, despite that, they argue that rates of dementia are actually declining. And so implicit in their argument, is that, maybe we've been overly focused on trying to target amyloid beta plaques and neurofibrillary tangles. There's even like a fun set of nicknames for the scientists who argue that Alzheimer's disease is largely driven by amyloid beta, or also called beta amyloid plaques. They're called the Baptists, beta amyloid plaques. And then there are the Taoists, right, who emphasize the role of neurofibrillary tangles, which are composed of a protein called tau. Taoists, right? So anyways, this is a whole separate discussion. It's really interesting in my opinion, but there is this kind of growing concern that's been there for a long time, by the way, right? At this point, like people were making this argument even when I was starting graduate school, and people were making it beforehand, but it was sort of starting to develop some inertia when I was starting graduate school almost a decade ago. And so, given the failures of drugs that do reduce amyloid beta plaques, given their failure to improve symptoms, what else might be accounting for what may be falling rates of Alzheimer's disease? Story for another day. Kind of interesting. Anyway, so the Baptists and Taoists aside, where does this leave us? Where does this study leave us? And so we should definitely eat a lot more basil. That's for sure, right? But not necessarily because of the study. But does this study suggest that, eating basil may reduce the risk of Alzheimer's disease? Not quite. Really what this study is indicating is that there may be a relationship between the stimulation of a receptor that's typically bound by short-chain fatty acids and changes in the brain that are associated with Alzheimer's disease, right? And it turns out that if you stimulate that receptor, that those short-chain fatty acids bind, those molecules that the beneficial microbes that inhabit our gut can produce. If you stimulate those receptors, we tend to see lower levels of the things that we know are associated with Alzheimer's disease. And we know that in people with Alzheimer's disease, levels of those short-chain fatty acids tend to be lower. So in other words, this is a new possible strategy to attack Alzheimer's disease, right? It's not necessarily suggesting that, eating a whole bunch of basil will prevent Alzheimer's disease. That said, it couldn't hurt. But what it's really, it's highlighting a potential connection between something like diet, lifestyle factors, and risks of Alzheimer's disease, right? And so, if you happen to cultivate a microbiome within your gut that tend to have high levels of these microbes that produce short-chain fatty acids that then, circulate up and then stimulate these receptors, then maybe it is that is accounting for why it is that evidently Alzheimer's or rates of dementia are declining, at least in the United States. I have to note that not everybody argues that rates of dementia are declining. But they're certainly not escalating super rapidly in the United States, and in higher income countries in general. But then also, another potential connection that this study would make is that if somebody lives a life of eating basil regularly, right, then perhaps you just get that sort of subtle low-level stimulation of that receptor. And so, you just have that system, that garbage disposal system, that recycling system via the lysosome. It just tends to be a little bit amplified, a little bit cranked up, right? In which case, the likelihood that beta amyloid plaques are going to accumulate is lower, right? That is the sort of connection that this study makes, at least in my mind. That said, it could very well be the case that, you take this molecule, fenchol, and it was among the most potent molecules that they found that stimulate that receptor, that FFAR2. You take that molecule and you tweak it this way and that, and then maybe you can get a much, much, much more effective molecule to stimulate that receptor, thereby reducing the accumulation of amyloid beta plaques. That's another potential, place that this study leaves us. Okay, so Frank says, so Scott says we should collaborate on making a new style of beer that highlights Basil, like a North Coast IPA or something. Yeah, dude, I'd be so down. I've never made a beer. I've been wanting to try it out for a while. I just don't really have enough space. And also I've had friends that made beer. Only once has it been like legitimately tolerable. But anyways, Stanley Scriven. I'm sorry. The text on this is so small. So Skirvin, or maybe I'm just getting older. Trans fats might be the real culprit. It's part of the story, right? Definitely. So yeah, let's get into that a little bit. So like, let's just stipulate that, rates of dementia are indeed declining in higher income countries, or let's just say the United States, right? What accounts for that? Well, the people that make that argument, despite the fact that we don't have any more effective treatments for Alzheimer's disease, what might account for that? Well, they would argue that, broadly speaking, lifestyle factors, things like diet, but then also the treatment of other ostensibly unrelated biomedical maladies like heart disease, diabetes. Effective treatment of those conditions has this indirect effect on reducing risks of dementia, right? We know that cardiovascular disease, first of all, heart disease is like the leading cause of fatalities, of health-related fatalities in the world. And we do have some pretty effective medications for heart disease, but then also there's been a broad recognition that like eating bacon every single day isn't necessarily ideal if you're not exercising. Not exercising isn't ideal. There is just a broader sort of awareness of the importance of these things. And so as a result, we know that heart disease, cardiovascular diseases are associated with dementia. Specifically Alzheimer's disease, but dementia in general, vascular dementia as well, right? All of them. Also, by the way, associated with stroke. If something's going wrong in your cardiovascular system, the brain will feel those repercussions in one way or another as we get older. And so, rather than just, having more effective treatments for Alzheimer's disease, it might just be the case that more effective treatments for heart disease and diabetes has this indirect benefit of reducing risks of dementia. Just, subtly, but still meaningfully. And as you're saying, right, like trans fats, definitely not the healthiest way to consume fat. And so just purely the recognition that not all fats are created equally. Not all macronutrients are created equally, right? Not all carbohydrates are created equally. A simple carbohydrate and a complex carbohydrate, take, let's say, I don't know, a Sour Patch Kids gummy bear or whatever, versus oatmeal or, whatever slow burning carbohydrates that take a while for your body to metabolize, to break down into the same molecules, into glucose, right? There's a big difference in the effects of eating those two delivery systems of the same molecules, glucose, right? There's a growing awareness of these things, and growing awareness that trans fats are bad as well, right? And so people just tend to eat them less. And then so over time, the various predisposing factors to Alzheimer's disease via the cardiovascular system, via, cholesterol alone, that may account for some of the benefits in dementia that we're seeing. Now, I have to note that like not everybody in biomedical science agrees that, this is a very significant decline in dementia. And Scott brought this up last time that, it may just simply be demographic effects, right? Like, the baby boomer generation has been getting older for a while now. And, younger generations are starting to begin to approach the age where, age-related conditions like Alzheimer's disease, dementia become a greater concern. But the baby boomer generation was gigantic. But, in my mind, it's almost certainly going to be a combination of both of those things where, let's just say Gen X and the millennial generation are just have a greater awareness. We just know more about human biology, about human nutrition. And so as a result, we do just live healthier lives. broadly speaking, obviously not everybody, right? We're talking about population level trends, but the diets of people 50 years ago, 60 years ago are kind of bananas. We're kind of ridiculous, right? And so now we sort of understand that. And then also just like the nature of exercise, how we exercise is also different. And so it's, it's almost certainly a combination of a bunch of these things. And so Scott says, if Baptists ever want to go to war with the Taoists, my money is on the Taoists. You think so? But yeah, I guess. Yeah. Yeah, maybe. But the Taoists are like, they can be a little spacey, right? Have you ever read the Tao Te Ching? It's kind of out there, dude. But I think I would probably put my money there too. And so Hannah says, Bill Gates' father died from Alzheimer's disease. Bill is afraid that he will die from it as well. Makes sense. Bill is giving money to researchers at Alzheimer's. Yeah, the Bill and Melinda Gates Foundation is a huge, huge funder of a lot of biomedical science. But, funny enough, the other founder of Microsoft, Paul Allen, he is probably the single, in terms of like private funding of biomedical science, if not he is certainly one of the most significant funders of basic neuroscience research. He even started an institute, the Allen Brain Institute, which I used very regularly when, in my research. But, and they do great research in general. But yeah, Paul Allen is a huge funder. He may be the most single greatest source of funding for biomedical science. But there's a bunch of other ones, the Kavlis, Robert Wood Johnson Foundation. I guess Robert Wood Johnson, I don't know if he's still alive. I don't think so. But, a lot of these folks do fund basic biomedical research. But when it's at the best, I think that the best examples of that relationship are when they just give cash to an institution that's doing good research and just say, do what you want to do. I care about Alzheimer's disease, but you do what you want to do with these funds, which is sort of different than how it works in the private sector. And generally speaking, I think it tends to be prudent for all of this research to be publicly funded, through an institution like the National Institutes of Health and the NIH. But yeah, I mean, you're right. You're absolutely right. And he is absolutely correct that, dementia in general, Alzheimer's disease certainly tends to run in families. And so if you have a family history of dementia, it is just something that you need, that is worth keeping in mind. And so hereditary, yeah, see, exactly. Yuck, bacon. You're growing basil behind you. Yes, I try to always have at least some basil growing. I used to have a ton of basil growing because I had one of those aero gardens, which are remarkably productive, just so effective. I actually changed out the lights in my aero garden to be even like brighter. But yeah, I used to have to give it away. I couldn't give enough of it away. I had so much because I was growing like 3 different types of basil, Genovese or sweet basil, actually 4, holy basil, purple basil, and lemon basil. And, I'm sorry, Thai basil as well. No, so I guess I didn't grow holy basil. I think it was Thai basil. Thai basil was my favorite, although purple basil is really good too. But yeah, when we moved, I just didn't have enough time, with the baby and everything. And also it's very bright. And I actually had it in like a chamber in my aero garden. I like set up these reflective panels. This is probably why it was so productive, because like all of the light was like, or maybe 80% of it was like kept within this little reflective chamber. But it takes up a lot of space, right? As small as it is, but it takes up a lot of space when you live in a small apartment. But anyways, yeah, I always try to have some basil growing. This, believe it or not, is just, I didn't have any growing. And I wanted to buy some basil. And so the grocery store, sometimes they'll have chopped up basil in like a bag or whatever, or not chopped up, but like just the leaves, destemmed, but they didn't have any that time. And sometimes they'll have this, where they'll have like a basil plant, essentially with roots growing in a bag with some water at the bottom. So I just got that and I used the amount that I needed. And then I just, kept doing it. And I've been fertilizing it. It's remarkable how important fertilizer is for basil to taste like basil and not just sort of like bitter leaves. If I just like left that in water, it tastes terrible. I've tried that out in the past just to see. It tastes awful, but just with like a tiny little bit of fertilizer, it makes a huge, huge difference. And so Paul Allen, rest in peace. Yes, I think so, Frank. I think he did pass away. Love Thai holy basil. Yeah, Thai basil is so good. I love Thai basil. And there are so many that I really, really want to try. Lemon basil is really interesting too. There's one called I think globe basil, which like grows as like an orb, which is really cool. There's a bunch. There's so many. I'm planning to Either if we move, definitely, but once I clean up this chaotic mess of an apartment, I'm planning on trying to grow more varieties because there are pretty meaningful differences. And so Scott says, my argument for Taoists is based on the historical proliferation of Chinese warriors being Taoist, as opposed to a bunch of pearl-clutching Baptists that are mainly known for telling people that they're going to hell for drinking a beer. Fair enough. Yeah. Gosh, what was it? Was it the Taoists that maybe they were Buddhists, that there's like this concept in hundreds and hundreds of years ago of, I think it was a Taoist who would walk around with like a jug of wine and a shovel. And the notion was they would carry those things because they just lived, they indulged in whatever they wanted. And, so if they keeled over, they would have a shovel that somebody could use to bury them. Don't let it flower, frustrate that plant. Yeah, exactly. I know. I had to learn that the hard way many years ago, to be clear. But yeah, that ruins everything. This one wanted to flower so much. It was just every day it was like a new little flower. But now it's over it. It's done trying. Yeah, it grows so fast. It's crazy. Do you use Miracle-Gro Fertilizer? Yeah, I think it is. It's specifically their herb mix, which is very different from their orchid mix. But I suspect that the orchid mix would be just fine. I mean, it's just ratios of phosphate, nitrogen, potassium, right? It's not that complicated. There's no plant hormones or anything like that in there, but it is definitely you can smell the difference. In just a teeny tiny little bit of that herb fertilizer goes a very long way. And for my orchid, and maybe you're very well aware of this, but for anybody who's interested, my orchid, which I think you can see behind me, it's right directly behind me. But anyways, I've had the same smallest bag of fertilizer you can get. I've had that same bag of fertilizer for as long as this orchid has been alive, which is over 7 years. Pretty crazy, right? All right. Yeah, don't let it flower, frustrate the plant. And then Scott says, now I have to buy a shovel, I guess. Yeah, got to be responsible. All right. That's what I have for you this week. So if you dig this kind of conversation and you haven't, maybe you'll consider liking and subscribing and doing all those kinds of things. Scott says, fun fact, vanilla is a member of the orchid family. I know. Yeah, for anybody who's unfamiliar with the way that they harvest vanilla, it is wild. It's so difficult. It's basically they have to pick it out of a flower, tiny little bits of vanilla. Saffron, or is that saffron? Or maybe it's both. Pretty sure it's vanilla too, though. Anyways, that's what I have for you this week. Yeah, so if you dig this kind of conversation about the brain and medicine and stuff like that, maybe you'll consider subscribing and liking and that kind of stuff. Thank you very much for the awards, Stanley. I really appreciate it. Otherwise, I will see you next week. See you, everybody.